This is the 11.3 mini lesson. So on page 563, what do surveyors, map makers, architects, engineers, and builders all have in common? All of these people use scale drawings. So here's our term. Scale drawings are representations of real objects or places that are in proportion to the real object or place they represent. The scale in a scale drawing is given as a ratio. Maps and blueprints are examples of scale drawings. So problem 1, the purpose of scale drawings is to represent either a very large or a very small object. This is one people often miss. The scale of a drawing might be written as, with a colon, 1 centimeter to 4 feet. It's, again, always the drawing to the actual, or I typically always call it model to actual. It can be written with a colon, it can be written as a fraction. This is going to be an easier way for us to do our mathematical calculations. The scale means that every 1 centimeter of length in the drawing represents 4 feet of length of the actual object. So by looking at that, I can tell that this one, the drawing, is going to be smaller, or my model is smaller than the actual. The scale of a map might look like this. 1 inch on a map is equal to 200 miles of actual distance. So we're going to write a sentence to describe the meaning of each, and I'm just going to take A and C. So if our map has a scale of 1 inch to 2 feet, that means for every 1 inch on the map, because remember it's model to actual, so I might put M and A, the actual distance would be 2 feet. So again, this is telling me my model is going to be smaller. 1 inch on a map stands for 2 feet, which is a much bigger measurement. Here, they're telling me a scale on a drawing is 2 inches to 1 inch. So again, this is model to actual. So that means for every 2 inches on the drawing or on my model, the actual is 1 inch. So if I think about that, if the actual is 1 inch and the model shows it as 2, I'm actually enlarging something. My model is bigger than my actual. And that's going to be something we have to really be able to identify in this lesson. So let's go to page 570, problem 4. So it says, which scale would produce the largest scale drawing? So that means the biggest model when compared to the actual. So right here, when I look at all these, there's no way for me to compare them because they're all in different labels. So what I want to do is be able to make them all the same. So I want to find the scale factor, which doesn't have labels. So right here, these are the same. So I can right away say that this is a ratio of 1 to 25. Here, these are totally different units. So I know that there's 100 centimeters in a meter. So I can rewrite this to say 1 centimeter to, instead of 1 meter, that's the same thing as 100 centimeters. Just like up here when the labels drop, now that the labels are the same, I can drop them and say this is 1 to 100. Here, I know that there's 12 inches in a foot, so because these are different, I can rewrite them both in inches and say 1 inch to 1 foot, which is 12 inches. Now these labels drop, so this is at a ratio of 1 to 12. Now, if I want the biggest model, it means the difference between the actual and the model will be the least amount of difference. So the least difference will make the largest model. The greatest difference makes the smallest. So which is going to produce the largest? That would be this one right here. The smallest model would be this one right here. They asked me for the largest model. This would be the largest model. So problem 2, which scale would produce the smallest scale drawing? So now I want the biggest difference between the model and actual. So here again, I see they're both in inches. So I can drop these labels and say this is a ratio of 1 to 10. These are both centimeters. These drop. So this is also at a ratio of 1 to 10. Here, I know that there's 1,000 millimeters in a meter. So 1 meter, or 1 millimeter to 1,000 millimeters. Now these labels can drop, and I get 1 to 1,000. So the smallest scale drawing would be this one right here, because it has the biggest difference between the model and the actual. Every 1 unit in the model stands for 1,000 units in the actual. So there's a huge difference between the model and the actual. Here and here, these are the same. 1 unit stands for 10 units in the actual. Not nearly as big of a difference as here. So number 3, the scale of a drawing is 6 centimeters to 1 millimeter. Is the scale drawing larger or smaller than the actual? So again, I want to get these to the same units. I know that there are 10 millimeters in a centimeter. So 6 centimeters is 60 millimeters. So here, in the actual, 1 millimeter in the actual is going, so 1 little millimeter, think of a real small amount, 1 millimeter in the actual is going to stand for 60 of them in my model. That means my model is larger than the actual. Now you guys might be wondering, when do you have a model that's actually bigger than an actual? And I guess a good way to look at it is, let's say you're looking at cells under a microscope. Those cells actually are so small we can't even see them with our eye. But when you go to maybe draw a diagram of it, think of science when you've made models of things. When you're making a model, it's like the size of a piece of paper, where when you're looking at it through a microscope, it's just puny. So that is when our model would be much bigger than the actual. Think of a billboard, and maybe it's advertising a box of cereal. You know what a box of cereal really looks like when it's sitting in your cupboard or on a shelf at a grocery store. When you look at that huge billboard, that's a model. That picture of a cereal box is way bigger than an actual cereal box. So those are some good examples to keep in mind of when a model is going to be larger than the actual. So now let's look at one more. Given a scale of 5 to 4, explain how we can tell whether the drawing is bigger or smaller. So again, it's 5 is the model, 4 is the actual. So for every 4 units in the actual, the model is going to be 5 units. That means my model is larger than the actual. It's really easy to do this when we either don't have units, because then I know the units are the same, or when my 2 units are the same. If they're different, like we had up here, we first need to make them the same so that we can make that comparison.